let us look at percentage purity. So this is another part, more concept that you need to understand. And this part, normally we are going to calculate the percentage purity. How do we do it? So we are going to use this question. 8 grams of impure sodium hydroxide reacted with exactly 40 centimeter cubic of 2.0 mole or 2.0 mole decimeter cubic of sulfuric acid. 8.0 grams of impure sodium hydroxide reacted with exactly 40 centimeter cubic of 2.0 mole per decimeter cubic of sulfuric acid. What is the first question that we are going to answer in this one? So the first question is, write the balanced chemical equation for the reaction with state symbols. So the first part, you are going to write the balanced chemical equation. Okay, write the balanced chemical equation for the reaction, include state symbols. Okay, now for you to write the balanced chemical equation, you need to know what are the compounds or what is reacting here. So what is reacting, you should take note that is sodium hydroxide. And how do you write sodium hydroxide? Sodium hydroxide, from the basic of the chemical formula, sodium hydroxide is written as NaOH. This is sodium hydroxide. Then also what is reacting? Sulfuric acid. And I urge you to know 4 strong acids. Okay, so one of them is sulfuric acid, written as this. Then the other one is nitric acid, written as this. Then this is 3. Then the other one is hydrochloric acid, written as this. Then we have phosphoric acid, written as this. So these are the ones that you're going to come across normally in these reactions. Okay, so in this one, we are going for sulfuric acid. Now, let us look at the reaction. So you know that the chemical equation here, what is reacting is sodium hydroxide and sulfuric acid. So we are going to have sodium hydroxide, which is in aqueous state, plus sulfuric acid, which is also aqueous, then to form a salt. Okay, so now this is where the problem comes in. This is where most of you find it challenging. Okay, so how do you know, or how do you write the formula of a salt? How do you write the formula of the salt that is formed? Now, in this one, or for you to know, is that a salt is the compound that is formed when the positive ion from the base react with the negative ion from the what? The acid. That is a salt. So, which means what is reacting here? It is sodium and sulfate in this one. Or in other words, sodium displaces the what? The hydrogen here, and of course in turn the hydrogen react here to form water. Okay, so what is going to form is sodium react with the sulfate here as a radical. So we are going to have you know that sodium has a valence 1 and sulfate has a valence 2 as a radical. So we are going to find sodium like this and sulfate, then plus water. And how do you know that water is formed? So please, these general reactions, you need to know them. When an acid reacts with a base, what is formed is salt and water only. It's a neutralization reaction. Okay? So what is formed is salt and water only. So immediately you identify the salt, or you write the formula for the salt, just know that the remaining one is what? Water. Whatever remains is just a matter of balancing the equation. Okay, and now how do you know that acid is aqueous? So all the acids that are used in the laboratory mainly are what? In aqueous state. There's some amount of water in them because you don't use them in the concentrated state. Mostly you dilute them. Therefore you add some amount of water. And now the resulting, when the aqueous and the aqueous react, what is out is an aqueous. Water is a liquid. Okay, so this is the equation. Now let us check if it's balanced, because they've told us to write the balanced equation with state symbols. Let us check if it's balanced. So to check if the equation is balanced, you are going to check the number of atoms of each, or the number of atoms involved on the reactant. So let me just write them here. Sodium, oxygen, hydrogen, and of course sulfur. Equally, the other side, what is involved is sodium, oxygen, hydrogen, and sulfur. So these, I'm just doing them for the sake of those who are coming across the concept of balancing for the first time. This is what you normally do. But in the case where you know how to balance, you can just use a pencil to try out numbers, then you clean them after you're done. So this is how you do it. Okay, balancing the equation simply means that what is on the reactant, this side, the whole of this one is called the reactant, and of course the whole of this one is called the product. So what is on the reactant should be the same to what is on the product in terms of atoms involved, and of course the amount. So here sodium 1, so sodium we have 1. This side sodium 2, then oxygen we have 1 and 4, so we have 5 oxygen. This side you have how many oxygen? 4 plus 1, you have 5 equally. Then what about in terms of hydrogen? This side you have 2 hydrogens, and also the other side you have what? 2 hydrogen. What about sulfur? Sulfur you have 1, and also sulfur you have 1. So what is not balancing is sodium. So here sodium is 2, and of course the other side is 2. So find a way of making this sodium 2, of which we are going to multiply this one by what? 2. Now, where the sodium here, for us to make it 2, we multiply outside the whole compound with a 2. So which means this 2 is multiplying everything here. It's not only multiplying sodium. Don't put a 2 like this. No, you need to multiply this in front. You need to put it in front. Now when you put it in front, it is multiplying everything. That is how you look at it. Okay, so this 2 that we've added here is multiplying everything. So which means sodium here, 2. Then what else is affected? Oxygen. This side is no longer 5. We are going to say oxygen 2 multiply 1, that is it, 2 plus this oxygen, which is 4 here, we are going to have 6. So we have how many hydrogen, oxygen this side? 6. But the other side we have 5. Then let us look at which one is affected. Hydrogen, we have 2 multiply hydrogen here, which is just 1. We have 2 plus this 2. So hydrogen is also affected. We have 4. What about sulfur? Sulfur remains 1. Now, the number of sodium remains 2. So sodium is balanced. Oxygen is, here is 6. Here is 5. Here is what? 4. Here hydrogen is what? 2. So we just find, first let us balance the hydrogen. So what number can we add in front here to make hydrogen? I mean, what number can we add to water to make hydrogen 4? Because it's only one that having hydrogen. So we find that we can multiply by 2. So a 2 added in front. Hydrogen is 4, but let us look at now, sulfur is still 1, 1. So whatever is remaining, we are just remaining with oxygen. So oxygen here is 6, oxygen the other side is 5. Now, with these 2 that we've added, 2 multiplied by 0, 2 multiplied by oxygen, 2 oxygen plus 4, we have 6. So hydrogen also has balanced, oxygen has also balanced 6. So the balanced equation, please don't write these. These are just there to help you as you try out numbers to balance the equation. These are not supposed to be there. Okay? So this is the balanced equation that you've written. Okay, now what is the next question? Write the net ionic equation. So this is the A, Roman numeral 1, for writing the balanced equation with state symbols. Then the second one is the net ionic equation. How do you write the net ionic equation? So for this one, you are going to split those that are in aqueous state, and of course you cancel out spectator ions. So let us split this one is in aqueous. So splitting this one is going to be 2 sodium ions plus 2 hydroxide ions. Just for this one, this 2 multiplies everything. You know that what is involved in sodium hydroxide are the ions of sodium and of course hydroxide. But how many are they? 2, 2. Then plus also this sulfuric acid is in aqueous, we split it. So you're going to have a 2 in front. This 2 you don't put it like this. Instead you put it in front. Then hydrogen ion. Then plus a sulfate ion like this. So we split on this other side. You even write my symbols. This side we only have this one in aqueous state. So we split this one is going to be 2 sodium ion plus sulfate ion. Then plus H2O. okay, H2O, which is in liquid state. All these are in aqueous. All these are in aqueous. All these are in aqueous state, okay, aqueous. Then what you do afterward? What you do is that you cancel out those ions that are common on both sides. And if you see from here, sodium we have, sulfate we have. So the net ionic will be 2 hydroxide ions, which are in aqueous state, plus 2 hydrogen ion. This is going to result into what is remaining here. So you only split those that are in aqueous state. The remaining ones, you leave them out. If they are in solid or in any other state, you leave them out. So this is the answer, and this one ends as a mark. Okay, so having explained that, let us look at the other question. The other question that we can solve from this one. The other question that we can solve from this one is calculate the number of moles of sulfuric acid. Let me just go back. Calculate the number of moles. So let me just clean this one. Moles of sulfuric acid that reacted with 8.0 gram of impure sodium hydroxide. Okay, so we are calculating the number of moles of what? Sulfuric acid. Now, in finding the number of moles of sulfuric acid, which formula are we going to use? And of course, before you even proceed to calculate the number of moles, ask yourself, what information are you given on sulfuric acid? So if you had to look at sulfuric acid, from the statement given here, we are saying 40 centimeter cubic of, so the volume of sulfuric acid is given as 40 centimeter cubic. And of course, the concentration is given as, or molarity is given as 0.0 mole per decimeter what? Cubic. Okay, now we want to find the number of moles. So you having concentration and volume, you know that the number of moles you are going to use the formula for concentration. Concentration is equals to number of moles divide what? Volume. If we are to make number of moles the subject of formula, we are going to find number of moles is equals to concentration multiplied by what? Volume. And therefore the number of moles of sulfuric acid is equals to concentration multiplied by what? Volume. But you should take note that the volume here is in centimeter cubic. You need to convert it into decimeter cubic. How do you do it? You just divide this one by 1000, or you can say 1 decimeter cubic is equals to 1000 centimeter cubic. What about 40 centimeter cubic equal to x? So you cross multiply, which is just the same as 40 divide 1000, and this one gives us 0.04 decimeter cubic. Try it out. Okay, so the volume we have it in decimeter. Concentration is given as 2. So we are going to multiply 2 multiplied by 2.0 more decimeter cubic multiplied by 0.04 decimeter cubic. Decimeter and decimeter goes 2.0 or 2 multiplied by 0.04 is 0.08 moles. So the number of moles of sulfuric acid is equals to that one. Okay, so the next question that we are finding is that, or that we are calculating is that, find the mass of pure sodium hydroxide from the solution that reacted with 40 centimeter cube of sulfuric acid. Find the mass of the pure substance that reacted with 40 centimeter cubic of sulfuric acid. So the ratio that we are going to find, or that we are going to form, is that of a sodium. So whether in pure or pure sodium, the molar mass still remains this one. So to what? To sulfuric acid. Okay, sulfuric acid. Now remember from the balanced equation, so the ratio that we form is that of sodium and sulfuric acid, because these are ones that we are reacting. And of course from the balanced equation we have this a 2 in front here. So this is the ratio that we are going to use to find the mass of the pure. Now how do we do it? So at this particular point you can say we can say 2 moles of sodium hydroxide reacted with what? We use mole to mole ratio, 1 mole of sulfuric acid. So 2 moles of sodium hydroxide reacted with 1 mole of sulfuric acid. What about 0.08 moles of sulfuric acid? What would be the number of moles of sodium hydroxide? Here the idea is to find the number of moles of sodium of pure. The number of moles that you are going to find are the number of moles of the pure because are the ones that reacted. Then after we find the number of moles, we go to the formula. Number of moles is equals to given mass over molar mass. Okay? Of which in finding the mass here, we are going to say mass is equals to number of moles multiplied by what? Molar mass. So this is where we are going. So before we go to this one, we need to find the number of moles of the pure. So how do you find it? You form a ratio of sodium hydroxide to sulfuric acid because they are the ones that are reacting. Now, from the equation, the ratios are 2 to 1. So 2 moles react with 1 mole of sulfuric acid. What about X moles of sodium hydroxide? Okay, react with what? 0.08 moles. So we need to find the number of moles of the pure sodium hydroxide here before we proceed to this formula. So here you cross multiply, and we are going to have 2 multiply this one, which is give us this one X is equals to 0.16. Okay, 16 what? Moles. So 0.16 moles are going to react 0.16 moles of 0.16 moles, I mean not 1.6, of sodium hydroxide react with the 0.08 moles of sulfuric acid. So this is the number of moles that we are interested in. Now after finding the number of moles, we are going to go into the formula now. Mass is equals to number of moles that we found is 0.16 moles multiplied by what is the molar mass of sodium hydroxide. So just the sodium hydroxide, what is the molar mass? So the molar mass, you find that sodium is 23, oxygen is 16, then hydrogen is 1. So it's more like 24 plus 1, I mean 23 plus 1, 24, plus 16, 40. So we're going to have 40 gram per mole. Now mole and mole cancels. 0.6 multiply 40, it is going to give you 6.4 gram. Okay, 6.4 gram. Confirm this is the mass that you found. So this is the mass of the pure sodium hydroxide. This is the mass of the pure sodium hydroxide. So that is how you simplify it. So in this one, we form the ratio of sodium to sulfuric acid as they are the ones reacting. So 2 moles of sodium hydroxide react with 1 mole of sulfuric acid. What about 0.08 that we've calculated? What would be the number of moles of sodium hydroxide that react? So after finding this one, then we apply this formula to find the mass, and we found it to be 6.4. Okay, so now what is the next question that we expect? Remember, the main reason for this lesson is to look at percentage purity. So the next question that we expect therefore is calculate the percentage purity. Okay, calculate the percentage what? Purity. Okay, that will determine the percentage purity of sodium hydroxide. Now percentage purity, let us write it like this. Percentage purity is equals to mass of the pure substance, okay, pure substance, divide what? Mass of the mixture, or pure divide the mixture. Okay, so mixture. The mixture is the impure, okay, impure substance, in this case sodium hydroxide. So what is the mass? And this one you should multiply it by 100. What is the mass of the pure? The mass of the pure we found 6.4. Divide, what is the mass of the impure? Is given in the question, 8.0 gram of impure sodium hydroxide, so 8.0 gram. Multiply 100, and percentage purity, percentage purity is equals to, okay, 6.4 divide 8 multiply 100. Be able to confirm this one should give you 80%, okay, as percentage what? Purity. So percentage purity here is 80%. So this is how you work out such questions. So please, you need to make sure that you know how to work out these questions. So thank you very much and see you in the next one. If you are interested in the online tuitions, you can get in touch on 0976402563. Otherwise, see you in the next one.